Alright, so we are going to pick up with mixed practice, and we're going to be given example problems that we're going to be simplifying. All these are expressions, again, not equations, because there's no equal sign. Okay? So, can someone tell me what does that operation mean in between? What are we doing? We're multiplying. Okay, so if we're multiplying, the 3 and the 5 will become what? 15. Now, putting the a's together, since we're multiplying, a to the what would happen? A to the 6th. Easy enough. They get more difficult as we go through, but we're going to start off a little easy. Now we have 3c to the 5th. The entire quantity is raised to the 2nd power. My question to you is, does this 2 apply to all powers inside of parentheses, yes or no? Yes. It does. Can you tell me why? It's subtle but huge and important because of the mistakes other people have as far as the other ones.
Isn't it 3 times c to the power 5?
Yes, it's because it's 3 times. Basically, this whole thing, if I were to ask you, how many terms do you see in the parentheses, what would you say? The answer is 1. Because there's one term that is glued together with multiplication. That's the difference, guys, okay? So real quick, subtly, I want you to know the difference. If it said this, would you distribute the 2 to the 3, and would you distribute the 2 to the 5? The answer should be no, because you have 2 terms. Think of them as islands, and the addition signs and the subtraction signs are the water in between, right? So these islands, you cannot distribute this 2 to both of them, because it's addition. Had this 2 been in front, then you could distribute the 2, but it would just be 6 plus 2, c to the 5th. I want you to understand the differences between these, because this is a huge common mistake, okay? But because of the fact that this is one term, you will in fact distribute to all of them. So it says 3 squared and c to the 5th, which will then be squared. Real quick, going back to this addition, if it had this 2, I want you to remember that means multiplicity. That means that you would have 2 of these that are carbon copies of each other, and then you would FOIL this out. And then you would be good. That's what you're doing if there's addition. Okay? So, 2 terms, FOIL out multiplicity of 2. 1 term, you can quote-unquote apply, aka distribute to all the powers that are in the terms inside of the parentheses. Okay? So, with this in mind, let's go ahead and simplify this. What does 3 squared simplify to? 9. And what would the c become? 10. C to the power of 10. Okay? That's kind of big. If you want to make a mark on your notes, that's fine. But that is a common mistake, misconception against within people who are at this level that you're at right now. What does 18 and 3 become? 6. And what happens with the z's? Subtraction. So z to the what? Z to the 4th. Another way to look at this, and I talked about this yesterday, is you have 7 z's up top, you have 3 z's on bottom. Visually, I'll remind you, there are cancellations of forms of 1, 1, 2, 3, so that you have 4 z's left up top, and then you would have z to the 4th power. Just another way to see it so that you don't make simple errors. Alright, looking at number 4. From what we learned yesterday, what would be the first thing that I would try to do, manipulate, rewrite, or what? Simplify the coefficients you can, but also rewrite negative powers. Okay? So let's look at 25 over 5. What does that reduce to? 5. Okay? That is up top in the numerator. And now, what I want you to do is concentrate on the ones that are negative powers, and I want you to move them physically and rewrite them. Since it's up top, this a squared would move to the bottom, becoming a positive 2. C would become a positive 4. And this D would go upstairs, basically, to become a positive 1. So that you have all of this. Does anything simplify from what you see? No, there are no common bases. So you're done. Okay? Most likely you, on your paper, would probably not write this because it would be understood and it would still be equivalent. Now I have 4 to the a times 4 to the c. What's the answer? 16. Careful. 16a plus c, right? So if you're multiplying with the same base, you're going to add the powers. If it was like this, that be? Not 16, but 4 to the AC. Okay, I just want to make sure that we understand the differences between them. That would be, sorry, not 14, but 4. And then this one down here would be 16 to the A plus C. Okay. 6. What would the answer be there? Perfect. X to the A minus B. Okay. All right, so now we're going to move on to number 7. What's the answer? 2 to the AB. Because you did what with the powers? Multiplied. Again, a good way to see that is that you see the parentheses in between A and B. All right. Let's look at number 8. Who wins A-wise? The top. By how much? 3. So you could look at it like that. Or if you want to do 7 minus 4 is 3, you would know it's in the numerator. You have 3, and what happened? Who wins with the B's? The bottom by how much? 2. Done. Okay? Those of you who chose to follow the rule explicitly, you would have -2, and you would have A to the 3rd. All of this is in the numerator, which the only thing that would move downstairs would be the B, and it would become a +2. Okay? Just make sure you don't leave your answers where their negative powers are left, but they actually are rewritten with positive. All right. What's another way I can rewrite this right here? Yeah, the cube root of 27. To the power of 1 if you want. Just want to visually remind you, the numerator is the power, and the root is out here with the square root symbol. And anyone, what's the cube root of 27? 3. Now, this was a little bit different. X to the -1/2. What would you suggest we do first? Anyone? So it is a negative power, right? Where I would probably want you to start
Put it into a fraction.
would be make it into a fraction. It's over an understood 1. So we know negative powers will move across this division sign, right? So x is going to go downstairs to become a +1/2. And I have a 1 left up top. Guys, did this 1 come upstairs to become this blue colored 1? No. So they were both understood where they're at, right? Without being written, they're understood that there's a 1 up top and there's a 1 up on the bottom. So this would be your final answer. Some people could write it like this, and I think the hands are going up. Could write it like this, and furthermore, we would know that we could rationalize the denominator, which means we're going to multiply by a form of 1, which would be what?
Root x over root x.
Nice, root x over root x. So that this bottom piece becomes x, and the top is root x. Okay, this is equivalent, but this one right here is the acceptable answer. The more acceptable answer. Okay. Let's look at angles of parallel lines. Again, you have been exposed to this information. What I'm trying to do is help you master it / store it in your memory, and maybe even process it a little bit different than what you might have before, just to ensure that mastery. There are 2 things that this diagram or picture basically revolves around. Okay? Can someone tell me what are the 2 things associated with this graph? So not complementary angles, but supplementary angles. Yes, you are correct. Supplementary. So 2 angles will add to get 180. Okay? What's the other thing that they could do? They're either going to add to 180 or they're equal. Okay? One more thing that I will add to this information that maybe you probably have never thought of, but it makes it easier to identify, which is what kind of angles do you have? You will either have this type of angle or this type of angle. Obtuse or acute. So if I'm looking for an obtuse angle, and I have an acute angle, obviously if I add these together, which one of these 2 will it be? 180. So if I add an acute with an obtuse, it's 180, nothing else, with this conceptual understanding. Okay, with this topic. How about if I had two acute angles? It would be equal. It would be equal. Not 90, but equal. How about if I had two obtuse angles? It would be equal as well. You with me? So, the acute angles are 1, 4, 5, and 8. All of those are acute angles. Are they all equal to each other? Yes. Easily they're equal to each other. So, the obtuse angles, if I showed you all the obtuse angles, they too would be equal to each other. And then there's formal names that we're going to discuss here in just a bit, so you know how to read the questions. What if you had, like I said before, this acute angle and any one of these obtuse angles? It would add up to 180. So 1 is supplementary with angle 2. 1 is supplementary with angle 3. 1 is supplementary with angle 6. 1 is supplementary with angle 7. Are we good? Okay. So now let's get some names and some terms in mind. Okay. Some people forget the terms, and believe it or not, one term actually changed from when I was in middle school learning geometry way back when to what they teach now. Okay. So here we go. Let's pick. So the following angle measures are supplementary. 3 and 5. Can someone tell me what makes 3 and 5 supplementary? Like, what's the formal name of it? Same side interior. So 3 and 5 are the same side interior, which would equal 180. Okay? They used to call this, back in my day, I don't know why they called it this, but they called these consecutive angles. It really doesn't make sense, because consecutive to me means 7, 5, or 7, 8, 9, 21, 22, 23. To look at 3 and 5 like a consecutive, it just doesn't make sense. So I think that's why they changed it to same side interior. But they are supplementary. How about 4 and 6? Same thing. Same thing. Okay. So also 1 and 2. Look at 1 and 2. And 6 and 8. What are they? Or say it says the following angles are supplementary. 1 and 2 and 6 and 8 are supplementary. Can you tell me why? They just make a linear line, okay? This right here was a misconception. A lot of people thought, including me when I was your age, that supplementary meant that they had to share that inside side of the angle. That 1 and 2 were supplementary, okay? But 1 and 7 were not, because they weren't touching right next to each other, like adjacent to each other. But that's not the case. Any two angles that add to 180 are supplementary. Okay? This is because it shares, but it's a linear line. That's why it's going to be supplementary. Okay? The short way to remember, like I've told you before, the obtuse plus the acute. Alright, so we have 1 and 4, 5 and 8. Guys, why are 1 and 4 equal? What's the formal name? Not alternate, but vertical angles. Vertical angles. Okay, a good way to look at that is that these angles are touching at the same vertex, and if you were to pull them apart, that vertex, to me I see two V's. So vertical angles. Okay? How about 5 and 8? Also vertical, right? 2 and 3 and 6 and 7, all vertical angles. Let's now do what other angles are congruent to each other and why. Alright, so let's create our list. We're talking about congruent, not 180 or supplementary. So 1 and 4 we said were vertical angles. Okay, how about 1 and 5? Now I want you to write this in your notes. 1 and 5 are what? They're equal, but they're equal why? What's the formal name for them?
Same side interior.
So they're not inside, they're both not interior.
Same side exterior.
If there was same side interior, they would be this. If there was same side exterior, they would be this. So they're corresponding. And the reason why I'm saying this, that you have to know this verbiage, is because of the fact that, especially on the ACT when you take that, they're going to give you a lot of words that they're wanting you to create the parallel lines. They won't necessarily always give you a picture. Alright, so 1 and 5 are corresponding. They are equal. How about... Okay, let's go back. 1 and 2, linear pair. Okay? How about 1 and 3? Linear pair. Okay? They are adjacent, but let's call them a linear pair to be supplementary. Okay? And then 1 and 6. 1 and 6. Are they equal? Or are they equal to 180? Equal to 180. Is there a formal name that ties 1 and 6 together?
No.
There's not. Okay. So now let's do 1 and 7. Are they equal or are they 180? Same side exterior, and they are 180. Okay? So 1 and 7, they're equal to 180. Same side exterior. And then finally 1 and 8. What are they? Alternate exteriors, and they're equal. So alternate exteriors, and they're equal. Are there any other formal names that we haven't mentioned? There's one at least. Not adjacent, because 1 and 2 were adjacent or a linear pair. 1 and 3 were adjacent, a linear pair. There we go. So 3 and 6. 3 and 6 are going to be equal, and they're alternate interior. Or 4 and 5 are alternate interior. That's it, guys. A good way to remember this, that I visually, one more thing before we move on, is that I kind of have students kind of see like this is the field, if you will. So this is like the football field, if you will. Alright? And exterior means that you're on the sidelines. You're not in the game right now playing. So anything outside of these parallel lines is considered exterior. Anything inside the parallel lines is considered interior. And just whenever you're competing against someone else and you draw the line, what is over here is alternate, the alternate team, than the other side of that line of scrimmage, if you will, if you want to give it a football analogy. Okay? Good way to remember just the words, because there's a lot of them. Alright, quadratic formula. Solve using the quadratic formula. We're going to get a little bit of practice, and I'm going to help you identify when and where you use this. First of all, this is the standard quadratic form, and this is the equation given. What I would want you to do, especially on the quiz that you're going to take today, is that we didn't discuss this quite yet yesterday. My question to you is, would I have to set this equal to 0? Yes or no?
Yes.
Yes. Now, there's a specific reason why you would set it equal to 0. Okay, sometimes you look at quadratics, you don't have to set them equal to 0. And sometimes you must set them equal to 0, otherwise you're going to forget or miss half of your answers. Can someone tell me why I have to set this equal to 0?
You need a C value?
Not the C value. It doesn't deal with the C value.
You have to set it equal to 0 so you can have a negative, because of the square root, isn't it? So there's a negative and positive.
You guys are kind of almost there. I know what you're saying about the C value. You want to move that C value so that you can see how this trinomial factors into two binomials. I understand that. But what about this original form of the equation tells us that we're going to have to set it equal to 0?
Because you're trying to find the intercepts.
Yes, but check this out. Look, x squared is equal to 9. You with me? Can you solve this? What would x equal? Plus or minus 3. What did you do? You just square rooted both sides. Did you ever have to set this equal to 0? The answer is no. That's what I'm trying to help you understand and remember, so you don't do too much or a little bit of work. Okay? But this one, I will have to set equal to 0. And I'll just go ahead and tell you. Anytime that you have an ax squared term and a bx term, you need to have those two. You have to set it equal to 0. Let me give you an example. What if I had x squared minus 2x? I know I've just set it equal to 0, but what if I did this? What would people probably do here, making a mistake? They would try to get this x alone, and this would reduce, and this would cancel, and this is the only answer that they would have. And they just missed half of their answers, okay? Because, again, when you have an ax squared and a bx term, anywhere in this equation, you must set equal to 0, because the thing that a lot of people overlook is what kind of factoring? 3-letter word, or 3-letter acronym. What kind of factoring? GCF. So this would come out as an x. You would have x minus 2, so that you have two answers. You have x is equal to 0 and x is equal to 2. Same thing we got here, but we would have missed this. So FYI, write it down, take note of it. Whatever you do, it's not just for me to tell you temporarily. If you have an ax squared term and a bx, you must set equal to 0. Okay, so let's go ahead and set 2x squared minus 4x minus 1 is equal to 0. And now comes the decision of, do we actually factor this by hand, or will we have to use quadratic formula? Okay, so I'm going to show you factoring maybe a little bit different than what you've been exposed to. Some people know the number sense and are really good with this and already know what I'm doing. And some people struggle a little bit because they would do factor by grouping on something. So my point is, I'm trying to show you a new way of factoring with quick, fast accuracy when this a value is other than positive 1. Okay, here we go, real quick. These two numbers will multiply to get 2x squared. What should they be? Well, 2x and x. The next thing, these two numbers will multiply to get a 1, not necessarily a negative, but a 1. So what are the factors of 1? Just 1 and 1. So this placement, it doesn't matter in this particular example because they're both 1 and 1. We're going to talk about ones that do matter today. Your goal is to now concentrate on this number and this number. This creates a 1x. This creates a 2x, which if I add together, I can get a 3. If I subtract, I can get a 1. But I need a 4. Do you understand what I'm doing right now? Because it's not there of what these 1 and 2's will create, I know that I'm going to have to use quadratic formula now. Okay? We're going to do more practice with factoring so that you can identify that, but also so that you can factor without having to do the quadratic formula. Because the quadratic formula takes a long time. Okay? So it's A is 2, B is negative 4. What's C? Anyone? Negative 1. Because you have to have it set equal to 0 before you see what A, B, and C are. So you have negative B plus or minus the square root b squared minus 4ac, notice the parentheses, all over 2a. Negative 4, positive 2, negative 1 gives us a positive 8. So all of this becomes positive 8. 14, or 4 squared, or negative 4 squared is a positive 16, plus 8 is a 24. And you have this right here that became a positive because of this double negative. And last, it's over 4. Okay? So now let's simplify the radical. And we talked about this yesterday. Let's see if you remember. When we're simplifying radicals, there's certain numbers that I'm thinking of as I go through. Can someone help me remind me, what was the first number that I would try to divide that by? 4. If that didn't work, what would the second number be? 9. That's 2 squared and 3 squared. Then you tried 16 and so on and so forth. This one can divide by 4. Okay? So I would have 6 and 4 which the 4 would come out as a 2. So I have 4 plus or minus 2 root 6 all over 4. Can you take the square root of this cleanly? No. So that's going to stay in there just as 6. What does the 4 in the denominator do to the numerator? Or it reduces it by 4, right? So this right here, this plus or minus, some people can see it the way it's written here. When I was at your age, I didn't see it that clearly, so I would on purpose separate these into 2 fractions. Okay? And then to know that I am only going to reduce the 4 with this one and the 4 again with this 2 and not the 6, I would do the following. I would rewrite this as 4 over 4 plus 2 root 6 over 4. That reduces, that reduces. So I have 1 plus root 6 over 2. And the other one would be what? 1 minus root 6 over 2. And yes, if you wanted to do that all together as a plus or minus, that would still work. Questions before I move on? Okay. So, using function notation algebraically. This is definitely algebra 2. The common mistake people make when they try to put this in here is that they forget to put parentheses. Because this is totally different than that. What's the top one equal to? 9, because it has a multiplicity of 2, and 2 negatives make a positive. And the bottom, what is that equal to? Negative 9, because of PEMDAS. Exponents are done before this multiplication order of operations. Okay? So, this is going to be a positive 9 times 3 is 27 minus 5 is 22. So f of negative 3, so go ahead.
Can you go back to that previous question? The what about the quadratic formula?
Yeah, did I skip something?
I think so. Because on the last step it was 4 plus or minus 2 root 6 over 4, and your final answer was 1.
What did I put it over 4 or 2?
You put it over 2, but should the 1 be over 2 or should the 1 be by itself? Because the 4 cancels out with the 4 to get over.
Oh, nice catch. So it's 1 plus or minus root 6 over 2. Nicely done. Yes, nicely done.
Could you also leave that as 2 plus or minus root 6 over 2?
Yes, you could also do, so we had 4 plus or minus
Root 6 over 2 root 6 over
2 root 6 over 4.
And you simplified it to 1 plus or minus root 6.
Nice. So do you all agree that this is correct?
Yes.
Okay. And thanks for catching this. I really appreciate it. This one also could be written as far as just reducing everything to 2, or by 2. So it would be 2 plus or minus root 6 all over 2. Because this reduced this by 2, and it reduced this by 2, so that its coefficient changed to a positive 1. Nice catch. Good. Good job. With right here, do we agree that this was correct? F of negative 3 was 22. Yep. Okay, so now look. I told you I'm going to show you different methods this week that you may not have been exposed to depending on your level of math. The common mistake here is that people will do this. They will write it in their notes just like this, and they make this a negative 9, and they've already missed it. Okay? So another way that you can do this, that a lot of my students, when they get to Calc AB and BC, they use different methods to ensure speed and accuracy, so they don't make simple errors. What separates national merits from non-national merits are simple errors. Okay? So, I have an x squared term, coefficient is 3. I don't have an x term, so I'll put a 0, and my constant is negative 5. This is called synthetic substitution, and you'll learn it in pre-calc. Not division, where you're trying to get no remainders, but just what you want to get as far as an answer goes. This will be our answer. We got f of negative 3. Our answer was 22. Otherwise, negative 3, 22, which is the input and output. Now, if I'm going to try -3, that goes here. I hope that some of you adopt this, okay? Because it is much faster and more accurate than doing it by hand. Because these numbers are sometimes bigger and they're cubed or to the 4th power and stuff. The steps are copy, multiply, and add. Okay? And then multiply and add. And there's your answer. Okay? I understand that this was an easy example. I'm trying to teach you this method for the harder problems. Okay? Just so you have more tools in your arsenal to do by hand without a calculator. Function notation with graphs. So g of -4, in case you don't already know it, means this. Looking at g of -4, it is asking you, and I'll highlight it as I go, what is the y value, that's like this outer piece, on g, because you could have many functions, where the x is equal to -4. So here's g. So on our g function, we want to know at -4, when x is equal to -4, what would the y value be? Okay? I know it's a little bit overkill, but some people don't know it that specific. Okay? So what is g of -4 on this graph? 3. What would g of -1 be? 2. What would g of 0 be? 1. And what would g of 3 be? 5. Okay? Now, this is asking something a little bit different. Notice we were given our inputs on all of these. And we found the y value. This one is a little bit backwards. They're giving us that the y value is 3. So that's like y value is 3. And we're trying to find all the places, all the k's, where this would be true. Okay? What do y'all say the answer is? Okay, so he's saying A or K, right? K. So K is greater than or equal to -5, but less than or equal to -2.
Oh, and also that one little in spot, 1/2.
And 1/2. Nicely done. Another notation that you could probably do it is from -5 to -2. And then you could just say n k is equal to 1/2. Some people are even more formal to write union with the set that contains 1/2. You
Put them out as a list.
can put them out as a well. You can put them out as a list, but here's the thing: you have infinite numbers between -5 and -2s. You know what I mean? So you can't. These are not talking about the integer values like -5, -4, -3, -2. It's saying all the decimals as well. So you have to show that, okay? All right, SOHCAHTOA with trigonometric functions. So trigonometric ratios, we have SO, opposite over hypotenuse, CA, adjacent over hypotenuse, TOA, opposite over adjacent. Okay. So, let's give these things numbers real quick. Because right now, can someone tell me, and you would understand it fully if you understood what I'm asking, what things are wrong right now as far as the way they're written? Or could be wrong? You have a hypotenuse written, you have an opposite written, and you also have an adjacent written. Opposite and adjacent. They could be different, because it all depends on what? The A and B. The trig value for sure, but where's the angle at? It depends on the angle. Because if I said, here we go, the sine, which is opposite over hypotenuse, from B, that means put your body where B is at. Guys, what's opposite? The way they have labeled, this is opposite, which that works, right? So you have opposite over hypotenuse. But if I put, what is the sine of A? And you put your body here, then the opposite is way over here. Do you understand? So Interchangeable are these two. They could be opposite or adjacent. Depends on where you're looking at it from. Okay, so what I want you to do, just for extra practice, I want you to go ahead and let's change this. Oh, not that. Let's change this to a triangle with sides. What was the Pythagorean triple that we learned yesterday? The very first one that's most common. 3, 4, 5. Let's do that. 3, 4, 5. Notice this. We're going to do the sine of A, the cosine of A, and the tangent of A. We're also going to do the sine of B, and the cosine of B, and the tangent of B. So remember, you guys said it, it all depends on where your body is, if you will. Put your body where the angle is at. So if your body is at angle A, imagine that you're standing there. Okay, you're right here. This will always be what? Hypotenuse, because it's opposite that 90-degree angle. So you tell me, guys, sine is opposite over hypotenuse. What does that equal? 4/5. Good. What's a cosine? 3/5. What is the tangent? 4/3. Now look at B. So put your body where B is at. What's the sine? 3/5. Cosine? Say again? 4/5. And the tangent? 3/4. Notice the relationship, guys. It's on the test. It's on all these tests. The sine of one of them is equal to the cosine of the other angle. They're interchangeable like that. And you learn that more in pre-calc. The cosine of A is interchangeable and equal with the sine of B. And last but not least, look at the relationship between the tangents. The tangent of one angle is the reciprocal of the tangent of the other angle. If and only if both of these angles are the acute angles of the right triangle. Okay, you can't do SOHCAHTOA from the 90 degrees. Okay, your body will never be there. Okay? Alright. Fractions, and then we're going to take a quiz. You'll have this right in your notes. I want to make sure I gave these out. Okay. Alright, here we go. Adding and subtracting. Common denominators. I can add these two because I have common denominators. Let me show you intermittent work. And what would I do with my answer? Simplify. Perfect, to 2/3, because they're both reducible by 3. Now, number 2 is 2/7 minus 3/2. Can I go and subtract them right now? No. So please don't make the mistake of saying -1 and 5. It's appalling when I see this sometimes. That's not how we subtract fractions, okay? The common denominators must exist first so that you can then subtract just the numerators or add the numerators, okay? Now, let me show you a little quick shortcut, but I'm going to show you the work first. What's my common denominator? 14. And the common denominator is achieved because I'm going to multiply each by a form of 1. What's the form of 1 for the first one? 2/2. Please don't just say 2, because 2/1 is what you're saying. So 2/2 is that form of 1. What's the form of 1 for the other one? 7/7. Visual, a few visual learners, so you have 14 and 14. Now you have what up top? 4 and 6, right? So we have 14, 14. You with me? Where's 21?
That's the top, right?
Oh, my bad. I looked at it as a 2. Thank you. So this is a 7. This is 21. So now we can bring this together. And what's 4 minus 21? -17. Can you reduce -17 over 14? No. So, look at all that work, guys. This is good practice, especially the way I initiated this, but I'm going to help you out of solving something faster. And what I'm about to show you, don't just use on these easy things. Use on the harder ones that are like x plus 2 over x minus 1 plus x over x minus 2 is all of this. I'm trying to help you out with that, with speed and with accuracy. Here we go. My hopes are when you see something that is adding or subtracting, only adding and subtracting, to get the common denominators that you multiply up. So 2 and 2 will give you this 4. Then multiply up. It'll give you this 21. And then multiply the denominators to get the 14 that you're looking for. So if you do it this way, you're going to go straight here and miss all that work. Okay? But it's practice, and I want you to get good at it. And then just simplify, and you get negative 17 over. Or combine and get negative 17 over 14. So cross multiply up, cross multiply straight across for your common denominator, and go quickly to that work. Questions? Okay, so look at this. Not so easy to do with that method that I just showed you if there's 3 of them, but you can still do it. You would just do 2 pairs at a time. Okay, but for this one, what I want you to do is concentrate on just getting all the common denominators together. Okay, so what are all the common denominators going to be? 6. What's the form of 1 of this guy? 3 over 3. And this one? 2 over 2. So you have 6, and now you just have to worry about this plus this minus that. You with me? Okay, so we have 3 plus 5 minus 4, which would be what? 4 6, which reduces to 2/3. Questions? Okay. Multiplication and division. Do I need common denominators? No. Okay, so a lot of people, whenever I asked you at the beginning of this unit, what topics do people struggle with? You said fractions, okay, and you were absolutely right. You do not need common denominators when you multiply and divide. You don't. Okay. But one thing that people do, unfortunately, is they multiply straight across, and then they try to reduce this. But that's a little bit too late. Okay, that's too much work. It's too difficult. You want to reduce as early as possible. Okay, here we go. So, look at 6, look at anything on the bottom, and reduce it if you can. You see what I'm doing? So what will the 6 and 3 reduce to? 2 over 1. Now some people last week, they struggled on these on the quizzes because they didn't cross-reduce. And finally, when they cross-reduced, they were able to get it near the end of the week. So try to develop this earlier on. What 4 numbers do you see right now that I'm still working with? There are 4 numbers here. 2, 2, 7, and 1. Does anything else reduce from top and bottom? No. So that's when you know, now I'm going to go straight across to get 4 and straight across to get 7. Okay? Alright. Very methodical. And this is the ones that they were missing on the quiz. Can the 10 reduce with anything that you see? It can. The 10 could reduce with the 4. So the 4 becomes a 2, and the 10 becomes a 5. Okay? Now look at it. Can any of the numbers on the top reduce with any of the numbers on the bottom? 13 and 26. Good. Which would be 2 and 1. Now look at it again like it's a fresh problem. Can any of the numbers on the top reduce with the numbers on the bottom? 2 and 2. And ultimately, you're trying to get these to as many forms of 1 as you can. Because the numbers that are left, guys, are the 5, 1, and 1, and the 1, 1, and 27. Nothing else reduces now. So you will multiply straight across to get 5, and straight across to get 27. And you don't have to ask yourself, if you did this correctly, you don't have to ask yourself right here, can this reduce? Because you've already reduced it. Okay? Let's go to this one. This one's probably throwing you off if you struggle with fractions. Okay? And you're going to do that. So what we learned in 5th grade when we divide by a fraction, it's the same as multiplying by its reciprocal. Okay? So everything else is going to stay 21, 20, 3, and 15. I forgot to ask you a question. Why can you cancel early on these fractions that we're doing? Let's answer that question. Why can you do this? Like, you know that you should, but why can you cancel early?
Because you're not changing the numbers. You're just changing what they're, like, you're not changing what they are, you're changing the numbers.
So you're changing just the proportion, right? The ratio. And the big thing that I'm trying to get you to say is that, do you see how we were just changing numbers and it didn't matter what number we changed as long as we were changing one from the top to one on the bottom? The big thing is multiplication does not have order. Order doesn't matter with multiplication. Okay? Alright. Look at what I have. What number up top can be reduced with what number on the bottom? 21 and 7. Here we go. 21 changes, 7 changes. 3 and 1. Now, fresh start. What numbers can reduce? Okay, so a lot of people have different numbers, and that's okay. I heard 20 and 15. I heard 3 and 3. I don't know if I heard 18 and 3. Okay? So, let's do 3 and 3. That's a little obvious, right? 1, 1. Now let's do 20 and 15. What does that reduce? 4 and 3. There we go. Now we can see 18 and 3. Is anything else reducible? No. So you don't have to worry about the answer of, okay, let's factor my answer, see if it reduces. You don't have to. You've already done that. So the answer is just what? 24. Nice. Okay, we have, I believe, 6 more. Yep, 6 more, and then we will quiz. Here we go. Now, I'm going to do the speed that I think you should be able to do this at. Stop me if you have a question, okay? So I'm looking at number 7. Immediately, M's go away. And then I see a 4 and a 5, which is 20. And I can do 10 and 2, which is also 20. I see 6 and 18, which goes to 3. And finally, I see n and n are canceled. And the last thing to reduce is the 25 and 20, and I'm dividing each of them by 5. I now have 4 terms. 5, a p, a 4, and a 3. Nothing else reduces and cancels, so I'm left with 5p over 12. Some of you probably did it even faster than that. Okay? Questions? Remember, order doesn't matter. So, let's first rewrite our fraction because it's dividing by a fraction, so keep, change, flip. Everything else still stays the same. And now I'm going to start canceling, reducing. I see this 5 and 10, which goes to 2 and 1. I see this 2 and 6, which goes to 1 and 3. I see this 11 and 22, which goes to 1 and 2. I see these A's go away. And now the things that are left are 1, 2, 2, 1, 1, 3, and the BC. So my final answer, because nothing else reduces from here, would be 4 over 3 BC. You agree? Okay. Let's move on. You will see mixed fractions at times, and the best way to do this is to make them into improper fractions first, okay? So if I'm adding and subtracting, I'm going to do 12 plus 2 is 14 over 3. 10 plus 1 is 11 over 2. And since I'm adding them with this new trick, I'm going to multiply up and write 28. I'm going to multiply up and write 33. I am adding them, And then I'm going to multiply across with the numerators to get a common denominator of 6. So adding 28 and 33, we get what? Say again? 61? No worries. 61 over 6, and that doesn't reduce. Okay? Let's do this one. So 4 plus 3, 7 fourths. 18 plus 5, 23 sixths. We are subtracting. Let's multiply up. Let's multiply up so that we get 42 minus, what is that, 92? All over, multiply the denominators together. 24. Okay? So 42 minus 92 is negative 50 over 24. So the difference between what I just did here, some of you will still try to go for the common denominator. We wrote the common denominator would be 24, but you could see up here the common denominator could actually be what? 12. So some of you might choose to do that early, and that's fine because you'll cancel reduce early. If you choose this way, just know you're going to have to ask yourself at the end, how does this reduce? And you can quickly just go by 2's if you want. Okay? So this would be negative 25 over 12. Does that reduce anymore? No. Done. Different ways, guys. Different ways to see and execute things. All right. We have 2x over 3 minus 1/4 is equal to 1. Okay? What is different from these problems than the ones that we just did? These are equations. They have the equal sign. We are solving for x. Okay. When I solve for x, can I multiply pieces by forms of 1? Yes or no? Yes, I can. I can. Okay? Or what I can do is multiply both sides by the same number, where it doesn't have to be a form of 1. You with me? All right. So your goal when you see this, how many of you, raise your hands please, how many of you would try to get common denominators? Okay, some people might try to get common denominators. And you're still going to be left with what? Fractions. Raise your hand if you don't like fractions already. Okay, a lot of people don't like fractions. So the reason why we don't like fractions, in my opinion, is because the denominator throws us off. So let's get rid of denominators as fast as we can. Here we go. What could you multiply this entire equation by? And when I mean multiply, you're going to distribute this number across all 3 terms. That would get rid of all denominators. 12. Nice. So here we go. Multiply by 12, aka 12 over 1. And guys, when I distribute this 12, watch very carefully. When I distribute this 12 on this first term, the 12 and the 3 will reduce to what? 4. You will multiply that 4 with what's left over, and you're left with 8x. Let's do this again. Distributing on the second one, this 12 and the 4 will reduce to what? A 3, which you will then multiply that 3 with the leftover numerator, because it's not always 1, but it will be a 3. It is subtraction. And what's going to be the number on the far right? 12. Look at this, guys. We're just multiplying all of this by one number. No fractions anymore. This is called the LCD, the least common denominator. Okay? We will add 3, divide by 8. Is it reducible? Nope. Done. Let's come over here. What can we multiply all of this equation by so we get rid of all denominators? 7. LCD. The first one becomes 35x. The second one becomes, and the last one becomes 21. So when I subtract the 4, I get 17, and I get 17/35.